let's move on to the next one here. So I'm taking a look at this, and I'm obviously going to choose the left side. It's way more complicated. I'm looking for squareds. If I see any squareds, then I might think of using an obvious substitution. I don't see any squareds right now. I don't see two fractions that we need to put together with a common denominator. I don't see already a fraction that would maybe require a conjugate. So it seems like maybe turning this to sine and cosine might be the best way, at least to start, just to kind of see what we have. So I've got sine, so I'll leave that, plus cos of x, cotangent is cos over sine. So I'm going to have to multiply those out. What's on the bottom here? Cosecant is 1 over sine. So it looks like I've got, on top, I've got a sine x plus cos squared over sine. Now, I know I'm going to need to put those together. That's got to be a fraction there. So sine x plus cos squared x over sine x. All over, on the bottom, I've got cos on the top, sine on the bottom. So just cos x on top, sine x on the bottom. Now, whenever I've got two fractions, and remember I do have two fractions, I'm going to have to merge them. I'm going to get a common denominator. So I didn't have that initially. Looking up here, I didn't have any common denominators or fractions, and now that I've changed it to sine and cosine, I do. So we actually just did this one. So I'm going to multiply by sine x, top and bottom. So on top, I'll have a sine squared. So sine squared. On the bottom is just a sine x. Plus, I've got this, cos squared x over sine x, all over cos over sine. So now I can merge these two together. And if you remember the last video, I'm going to get sine squared plus cos squared, and that is a trig identity. A Pythagorean, an obvious substitution will be needed there. So I've got sine squared plus cos squared. That's me adding the tops of the fractions together, all over the common denominator, which is sine x, divided by cos over sine. And the obvious substitution here is that sine squared plus cos squared is equal to 1. That is on our formula sheet. Sine squared plus cos squared equals 1. So I just have that as it is. Sine squared plus cos squared, that's just 1 over sine x divided by cos x over sine x. And so I've now found myself in a situation where, and I actually found myself in that situation at the very beginning, where I had a fraction on a denominator. So I'm going all the way to the top here. Once I put these together, right there, they're put together, that was I've got a fraction, and the bottom of the fraction was also a fraction. And whenever I have that, I could move it to the top and flip. Now, I didn't do that yet. I was kind of just trying to figure out all this stuff first. But now you can see cos x over sine. It's been hanging around on the denominator this whole time. Cos x over sine, cos x over sine. So now I think it's time to bring this to the top and flip it. It's a trick that we often will use whenever we have a fraction on the bottom of a bigger fraction. So I'm going to flip that. So I've got that 1 over sine still. And when you flip things, you can turn it to a multiply. So I've got that multiply here, and I'm going to flip it. And what I end up having now is sines cancel out, and I just have a 1 over cos. Now I'm out of space here, so I'm going to write it right here. I'll move it later on. But I have a 1 over cos. And that is just the definition of secant x. So is that my right side? I'm going to have to zoom out here. There's a lot that went on. It is secant x. So I've done it. I've proved it. It becomes left side equals right side. I'm going to have to clean this up for the actual key, but that's everything. That's a lot of work that we did. We turned things to sine and cos, which gave me this, which required a common denominator. So I did the common denominator. Then I had to use an obvious substitution to make that a 1. And as if that's not enough, I had to take my bottom fraction, flip it to the top. And then things could cancel out. So let's take a look at this. I don't know what side is more complicated here. I think the left might be because it's got a fraction. So I'm going to merge them. So because I have a fraction and a number, I basically have two fractions. We have to remember that. So this is 1 over cos minus cos of x over 1. And remember, it's still a fraction, it's just over 1. And I can get a common denominator. This has a cos, so I'm going to leave this, multiply this by cos as well. That way the left and the right will both have a cos. So I have 1 over cos. I'll make it a little nicer. 1 over cos of x minus cos times cos is a cos squared over cos of x. So now that they have a common denominator, I can push them together. 1 minus cos squared. It's going to be pushed together on top all over cos of x. Now that does not look like what I have up here, but I have been looking at obvious substitutions and I see a cos squared and a 1. So if I look at my thing here, cos squared and 1, this is a cos squared and a 1, but they're on opposite sides. I'm going to need to move things over. So sine squared plus cos squared is 1. Let's write that obvious substitution down. So sine squared x plus cos squared x equals 1. And I have the 1 and the cos, 1 minus cos. I got those both on the same side. They're both up top there. So I'm going to need to get these both on top. So let's move the cos squared over. So I'll move this over to the right side. So on the left is just a sine squared. And on the right is a 1 minus cos squared. So sine squared is equal to 1 minus cos squared. Or if I see a 1 minus cos squared, I can write it as a sine squared. So that's what I got to do here. I got to rewrite 1 minus cos squared as a sine squared. I'll write that in green. So we're doing a lot of algebraic manipulation here. So let's take a look at what I've done so far. I picked the left side because I had a fraction. In order to get these two fractions together, I had to write it as cos x over 1, get a common denominator. I pushed them together to get 1 minus cos squared, which turns out it's a sine squared x. That's an obvious substitution. That's still not what I need. But this is what's weird. I need a sine and a tan. Tangent is sine over cos. So I need, if I'm looking at this, I can't do the right side, but I'll do this a little bit. Sine is just sine. Tan is sine over cos. So I basically have a sine cos, or a sine squared cos. Well, I have a sine squared cos here. So what's the previous step is to write it sine twice. So what's what I kind of need to do here? I use the right side to see how do I get this backwards. So I have a sine squared. It's not obvious that really I should write that as sine times sine. But then if I do that, that is just a tan. So I really just have a sine x, and this one I can leave on its own because that will just become the tan. So it's about taking this sine squared, knowing to write it as sine twice, and then pushing one of the sines off to the side so that you could make this thing a tan. None of that is intuitive. That's a really big jump to make. Sine squared. Turning that sine squared into two sines. But that's it. You end up getting sine x and tan x. So left side equals right side. I don't know if I can have, let's see. This might work. We'll see if I can give this a shot. This is the one where you can see it. You've got 1 minus sine. The conjugate of 1 minus sine is up there, 1 plus sine. And usually you'll see that. So let's give it a shot. I'm going to multiply this side by the conjugate, 1 plus sine. And if you do this enough, you'll know this trick. Often you can see the conjugate somewhere else in there. Not always. So I'm going to multiply this out. So 1 times 1 is going to be 1. 1 times sine is sine x. Sine x times 1 is negative sine x. Negative sine times positive sine is just going to be a negative sine squared. Now, as if that's not difficult enough, the top, again, none of this is intuitive, but if you do it enough, it will become a little bit easier. I'm actually not going to multiply. I'm going to leave as just cos of x and 1 plus sine x. And I know that because at the end, I need to have a 1 plus sine x on top. So I'm going to leave that 1 plus sine x on top. These are gone. So I've got a cos of x on top and a 1 plus sine x. And on the bottom, I've just got a 1 minus sine squared. 1 minus sine squared. Now, this is another time where we see that identity. I think it's almost like, is it almost the same? Let's see what I have for this obvious. Yeah, this one's 1 minus cos squared. We're now just having 1 minus sine squared. So I'm hoping that you'll get to the point where you can just see, I'll write it down after, but you can just see that 1 minus sine squared is just cos squared. We're hoping you get to that point where you can just recognize that. And then now you've got a cos x on top with 1 on the bottom. So I've got that 1 plus sine x that I liked. And on the bottom is just a single cos x. And I believe that is my right side, or my left side. 1 plus sine is equal to cos. So it's this idea of multiplying by the conjugate. I could see it on the other side. And canceling out the middle part, so that's what conjugates will do. And then using the identity, 1 minus sine squared is cos squared. And then cancel out anything. And it's also knowing that you're not going to multiply the tops. Because I want to have that 1 plus sine x on top. I'm going to leave it as a 1 plus sine x on top. I'm not going to multiply that cos in. So left side equals right side. We'll do a bunch more that have conjugates as well.